Okay, so hopping back into the article here, I have a few. Well, we can go through some of these insights, and then actually, I want to just kind of talk about, kind of expand on some of these statements, right? So, number one, you are lucky if 99.999% of the time network is not a problem. So, this is talking about the reliability of networks. I think this is more for senior engineers and more for those people who kind of work in the networking space as it relates to tech and engineering. So it refers to how difficult it is to maintain high network reliability, even for companies with specialized infrastructure like Google. Issues still arise. It is impressive to have near perfect network uptime, but the reality is that networking issues still contribute to a small percentage of overall system failures. Um, let's continue here. So we have another one, number two says, ACID has many meanings. Now, let's see, let's scroll down a bit here because we'll just go through. They have descriptions here for each one, so we'll go through the actual descriptions as well. So we've already kind of touched on that one. So acid has many meanings, so we'll kind of save that one for last. I just want to keep let's just kind of expand on the network issue and just keep it here for now because this is a long article. It can become long-winded. Um, so let's talk more about Google's experience with networking. So as we can see here, Google, for example, claims its global database Spanner has an impressive 99.999% uptime. However, even they report that 7.6% of Spanner's issues come from networking, despite their extensive custom-built infrastructure. So this highlights that even with the best resources, networks are still a weak link in distributed systems. So the debate on networking reliability, I didn't know that this was something that was debated. I guess it's more debated among professionals, like I said, who work frequently with networking. But it can pertain to a software engineer, just depending on how involved your job role is and what kind of engineering you're doing. But the reliability of networking is debated. So a classic assumption in distributed computing is that the network is reliable. But this is often disproved in real world applications, especially outside the largest organizations. Smaller companies or public internet users lack the dedicated networking resources of major players like Google, which means their systems are even more vulnerable to networking failures. Also, expanding on the lack of comprehensive data. So there is limited data on how reliable networks are, especially outside of large tech companies. Smaller organizations don't have the infrastructure or visibility into the networking issues to accurately measure the extent of their problems. When large cloud providers like AWS or Google Cloud suffer outages, it can affect entire portions of the internet. But these are just the high-profile cases. Many other network-related issues happen without making headlines or being fully understood by customers. So moving on to network failures and the actual causes. So common causes of network outages include hardware failures, configuration errors, and even power failures. These are all conventional problems that continue to plague networking systems. More surprising cases or causes of networking issues, like shark bites, literally sharks biting underwater cables, yes, demonstrate that unpredictable factors can also impact network reliability. So, you know, and that's crazy. Like, and that's something that's new, but it's something that, how can you predict that there's going to be sharks attacking the cables underwater, and that's going to affect your networking, right? Companies probably thought they were smart, having networking ran underwater, right? But anyways, I had no idea about that, so that's actually pretty pretty cool, and I guess it's not good at the same time. But the black box, let's talk more about the black box problem. So many cloud customers don't have insight into their networking problems when they happen, because third-party services often act like black boxes. Users can't always pinpoint whether their outages are due to network issues or on the provider side. Now, networking is always tricky, and this is one of the main reasons why. It's just visibility, right? You don't have that insight. So the key takeaway here is that networks are still a major source of outages, even for the biggest tech companies. While these organizations have the resources to reduce network failures, most smaller companies don't have the same level of control or visibility. So the perception that networks are reliable is often challenged. And with unpredictable issues like shark bites, networking problems can arise from unexpected places. So this poses a unique challenges in the AI systems and distributed software engineering, where high availability is critical, especially in AI. So, yeah, what do you guys think? Leave your comments below. That's it for this video. I'm going to go ahead and wrap it up. Check out AI Dev Now for courses and content so you guys can future-proof your career and start learning how to utilize AI to your advantage before it takes over potentially. So that's it for this one. As always, keep coding. Bye.